Hello everyone, welcome to this lecture video. In this lecture video, we are having the operating system issues. We are going to discuss the operating system issues here. So, major OS jobs are to manage physical devices and to present a virtual machine abstraction to applications. So, we are talking about the OS issues. Issues is nothing but for hard disk. The OS provides two abstraction: raw devices, an array of data blocks, file system, the OS queue, and schedules the interleaved requests from the several applications. So raw devices, file system, etc. Then application interface can be a most OSs handle removable disk almost exactly like a fixed disk. A new cartridge is formed and the MTM file system is generated on the disk. So the tapes are presented as a raw storage medium, and application does not open a file on the tape. It opens the whole tape drive as a raw device. Usually the tape drive is reserved for the exclusive use of that application. Since the OS does not provide file system services, the application must decide how to use the array of blocks. So since every application makes up its own rules for how to organize a tape full of data can generally only be used by the program that created it. So these are application interfaces here. The tape drives, the basic operations for a tape drive differ from those of the disk drive. So locate position is the tape to specific logical block, not an entire track, correspond to seek. So read position operations returns to the logical block number where the tape head is used here. The space operation enables the relative motions. The tape drives are up and only devices updating a block in the middle of the tape. Also effective erase everything beyond that block. An EOT mark is placed after a block that is written. So that is the thing we are discussing here, tape drives and file naming. Issue of naming files and removable media is especially difficult when we want to write data on a removable cartridge on one computer and then use the cartridge in another computer. So contemporary OSs generally leave the namespace problem unsolved for removable media and depend upon the application users to figure out how to access and interrupt the data. Some kinds of removable media, example CDs, are so well standardized that all computers use them the same way. So file naming can be used in here. Then hierarchical storage management. A hierarchical storage system management extends the storage hierarchical beyond primary memory and secondary storage incorporated to the tertiary storage. So here usually implemented as a jukebox for a tape or removable disk. So usually incorporate a tertiary storage by accessing the system. Small and frequently used files remain on disk. Large old inactive files are archived to the jukebox. So HSM is a hierarchical storage management here. It's found in the supercomputing centers and other large installations that have enormous volume of data. So in this speed, we are talking about speed here. Two aspects of speed in tertiary storage are bandwidth and latency. So bandwidth is measured in bytes per second. So sustained bandwidth, average data rate during a large transfer, data rate when the data stream is actually flying. So effective bandwidth, average over the entire IO time including seek or locate, and cartridge switching drive overall data rate. Then speed, access latency, amount of time needed to locate the data. Then access time for a disk. Move the arm to the selected cylinder and wait for the rotation latency. So less than 35 milliseconds. So access on the tape requires finding the tape reels until the selected block reaches the tape head. Tens or hundreds of seconds. So generally say that the random access with a tape cartridge is about thousands times slower than the random access on disk. The low cost of tertiary storage is a result of having many cheap cartridges share a few expensive drives. So removable library is best devoted to the storage of infrequently used data because the library can only satisfy a relatively small number of IO requests per hour. So reliability, we are talking about reliability here. So fixed disk drive is likely to more reliable than a removable disk or a tape drive. Then optical cartridge is likely to more reliable than the magnetic disk or tape. We are talking here the head crash in a fixed hard disk generally destroys the data. whereas the failure of a tape drive or optical disk drive often leaves the data cartridge unharmed. Then West, we are talking about here cost. Main memory is much more than expensive than disk storage. The cost per megabyte of hard disk storage is competitive with magnet tape if only one tape is used per drive. The cheapest tape drives and the cheapest disk drives have had about the same storage capacity over the years. The tertiary storage gives a cost saving only when the number of cartridges is considered larger than the number of drives. Then price per megabyte of DRAM from the 1981 to 2000. Here this is price here. Then price per megabyte of magnetic hard disk from 1981 to 2000 here. Then price for tape driven from 1984 to 2000, etc. Thanks for watching this OS basic things on how the magnetic tapes and year graph, or how it learn from this, how the revolution changing the storage devices in the using in the operating system. Thank you.